Let's now discuss problem number 3. In the beam section shown, it will be subjected to a service dead load of 215 kN. So sinabi na service dead load. So meaning to say, unfactored pa yung mga loads natin dito. Yung 215 natin, hindi pa siya naka-ultimate. What is the safe service live load moment? So hanapin natin yung live load moment natin na unfactored. Use F'C 21 megapascal. Your Fy is 415 megapascal. And use NSCP 2015 provision. So for this one, hahanapin ngayon natin yung value ng moment natin sa live load. So kung mapapansin natin dito sa figure natin, meron tayong 8 pieces ng 25 mm diameter sa tension bars. And for the compression bars, meron tayong 5 pieces na 25 mm diameter. And meron tayong clear concrete cover from the top of your reinforcement, dito sa pinakataas ng reinforcement, to the outermost fiber of your beam na 30. So meaning to say kung 30 to, so dito din is 30 din. So meron din tayong clear concrete cover dito na 30. So bago natin ma-solve muna yung mga problem natin dito, kailangan muna natin malaman yung value ng effective depth natin. Again, yung definition ng effective depth natin, from the center of your reinforcement to the outermost fiber ng beam natin in compression. So yung buong, so if we will going to draw that, eto yan, from the center of your reinforcement to the outermost fiber in compression, that is the value of your effective depth. Now, that is, so yung total depth natin, that is 650. So, ganun lagi, no? Centroid yung reinforcement natin. So, minus yung clear concrete cover natin na 30, minus yung isang diameter natin na 25, minus yung kalahati natin na 25 over 2. And that is the value ng effective depth natin. Now, the value of your effective depth is now equal to 582.5 mm. How about naman yung D prime natin? Or the distance ng reinforcement natin from the center of your reinforcement to the outermost fiber natin in compression naman. So, paano natin i-compute naman yan? So, from the center ng reinforcement natin to the outermost fiber, that is D prime. So, hanapin ngayon natin yung value ng D prime natin. So, yung clear concrete cover natin plus yung kalahati ng diameter ng reinforcement natin. So, you will have a value of your D prime which is now equal to 42.5 mm. So, after nating makakompute yung effective depth at saka yung D prime natin, let us now proceed to step number 1. And what is your step number 1? We will going to check kung totoo bang DRB yung sinosolve natin na biga. So, first step, check if that is real. Check if real DRB. Sir, paano po natin i-check yan? So, we can check that by means of computing for the value of your raw actual. So, raw actual, that is AS over BD o yung steel reinforcement ratio natin. So, meron tayong 6 na piraso ng 25 mm na diameter over yung base natin na 360 over the effective depth na 582.5. So, you will have a value which is equal to 0.01873. And yung raw max naman natin, using the formula 0.85 F'C beta over Fy multiplied by 3 over 7. Since yung value ng F'C natin, that is less than to the limiting value natin na 28 megapascal using NSCP 2015. Therefore, the value of your beta that is equal to 0.85. And you will have the value of your Fy which is equal to 415 megapascal. Yung F prime C naman natin that is 21 megapascal. Therefore, Rho max is now equal to 0.01567. Since Rho actual is greater than to the value of your Rho max, therefore, doubly reinforced beam tayo. Then, for the next procedure, we will use yung compression is equals to tension. We're going to assume that compression still will yield, so that is Fs prime is equals to Fy. So, ano yung mga tumutulong sa compression natin? So, yung C1 natin, that is caused by the, yung compression block natin, plus yung C sub 2 naman, that is yung bakal natin sa compression side equals T. So, assuming na nag-yield yung bakal natin sa compression bars, so you have C1 is 0.85 F prime C AB plus yung C2 natin that is AS prime. Fs prime natin magiging Fy is equals to AS. So, yung Fs natin sa tension, that will become Fy. Kasi mag-yield yung bakal natin sa tension side once na nag-doubly reinforced beam tayo. So, with that in mind, so let us now compute for the value of your compression block. So F prime C that is 21, yung A natin yun yung hinahanap natin, multiplied by B na 360 plus yung AS prime natin meron tayong 5 piraso na 25 mm squared, 25 mm diameter, multiplied by 415 is equals to meron tayong 8 pieces of 25 mm squared multiplied by 415. So we can now calculate for the value of your A, which is equal to 95.104 mm. Then, makukuha natin yung value ng C natin, 95.104. Divide lang natin siya to the value of your beta na 0.85. So the value of your C is now equal to 111.887 mm. And for the next step is we're going to check our assumption. Sir, paano po natin i-check yan? Let us now calculate for the value of your Fs and for the value of your Fs prime. So Fs muna, 600. Yung D natin, that is 582.5 minus yung C natin na na-compute na 111.887 over 111.887. So the value of your Fs is now equal to 2,523.687. Since it is greater than to the value of your Fy, therefore, tension still yields. Next naman, doon naman tayo sa compression steel bars. So that is 600 multiplied by C minus D prime. So the value of your C that is equal to 111.887 minus yung D prime natin which is equal to 42.5 over 111.887. So the value of your Fs prime is now equal to 372.091, which is less than to the value ng Fy natin. Therefore, assumption incorrect. So, compression steel bars doesn't yield siya. So, para ma-confirm natin kung hindi ba talaga nag-yield yung bakal natin or hindi. So, we're going to recompute yung value ng compression block natin. So, gagawin natin, since incorrect yung assumption natin, recompute tayo. So, magre-recompute tayo ulit. But by this time, recompute tayo ulit tayo sa step 2 natin. Ngayon, mangyayari niyan is, gagamitin na natin yung value ng Fs prime natin na 600, C minus D prime, over C. So, hindi na kasi yung Fs prime natin, we will going to assume na hindi yan mag-equate to the value ng Fy natin. So, with that in mind, gamitin na natin itong formula natin sa Fs prime. So, ulitin natin. So, we have yung C1 plus C2 natin is equals to the tension. So, yung C1 natin, that is 0.85. F prime C. So, what is the F prime C here? That is 21. Multiplied by A, yun yung hinahanap natin. Yung B, that is 360. Plus, yung AS prime natin dito. So, we have 5. Meron tayong 4 na piraso ng 25 mm diameter bars. So, multiplied by natin by the value of your Fs prime. So, ano yung value ng Fs prime? That is 600. C minus D prime natin. Ano yung value ng D prime natin? That is 42.5. Over yung ano natin dito, yung namin ito, that is C, equals, so yung AS natin dito, that is equal to, meron tayong 8 na peraso ng 25 mm diameter bars. So meron tayong 8 pieces ng 25 mm diameter bars. Tapos yung ano natin dito, Fs natin, that is equal to Fy na 415 megapascal. So yung A natin dito, that is equal to 0.85 of C. 0.85 of C. Bakit sir? Bakit 0.85 C po yan? Kasi nga, yung beta natin dito, that is equal to 0.85. Wherein yung A natin, that is equal to beta multiplied by C. So substitute lang natin yung A natin dito. So in terms of C na lahat. So in terms of C tayo dito. In terms of C tayo dito, by shift solve, we can now calculate for the value of your C. So what is the value of your C? That is equal to 122.384 mm. So after nating makuha si C, kunin naman natin si A. So that is equals to beta multiplied by C, 0.85, multiplied by 122.384. So you have a value of your height of the compression block, which is equal to 104.026 mm. So with that, we will going to check ulit. Proceed tayo sa step 3 ulit. We will going to check our assumption. So, kunin natin yung Fs natin. And kunin natin yung value ng Fs prime natin. So, Fs that is 600. Yung D natin, that is 582.5. Minus, yung C natin, which is equal to 122.384. Over yung C natin na 122.384 is equals to, so you have a value of 2,255.77 megapascal. Then, yung Fs prime naman natin, 600, multiplied by yung C natin na 122.384, minus yung D prime natin na 42.5, over yung C natin na 122.384. So, you have a value of your Fs prime, which is equal to 391.639 megapascal. So, titingnan natin dito yung Fs natin na greater than siya sa value ng Fy natin. Therefore, tension still yields. Ito naman, yung Fs prime natin nag-less than siya to the value of your Fy, which is equal to 415 megapascal. Therefore, assumption correct. So, compression still doesn't yield. So, kapag hindi nag-yield yung bakal natin, so gagawin natin is, magre-recompute ulit, no? Pero dito, tama naman yung assumption natin. Nalaman na natin yung nature ng compression steel bars natin na hindi siya mag-yield. So we will now proceed dun sa pagkuha ng service live load natin. So paano po natin gagawin yon? So para ma-solve natin yan, we need to refer to the value of your ultimate moment capacity that is equal to the reduction factor multiplied by the nominal moment. So first of all, kunin muna natin yung nominal moment natin. So with that, hanapin na ngayon natin yung value ng nominal moment natin. So what is the value of your nominal moment? So nominal moment, that is equal to C1 multiplied by the moment arm na D minus E over 2 plus C2, yung ano natin dito compression steel bars multiplied by the moment arm of D minus D prime. So for this one, Mn is now equal to 0.85 F prime C AB multiplied by D minus A over 2 plus AS prime. Ngayon gagamitin na natin dito is FS prime na. Okay? Kasi nga hindi nag-yield yung bakal natin. So, nominal moment, that is equal to 0.85. The value of your F prime C na 21 multiplied by yung A natin na nakuha natin na 104.026 multiplied by B na 360 multiplied by yung D natin na 582.5 minus yung A over 2 plus yung value ng AS prime natin. Meron tayong 5 piraso ng 25 mm diameter bars multiplied by the value ng FS prime natin, which is equal to 391.639 multiplied by the moment arm na 582.5 minus yung D prime natin na 42.5. So the value of your nominal moment is now equal to 873.678 kilonewton meter. So for this one, yung problema na lang is what will be the value of your reduction factor? So paano po natin kukunin yung reduction factor natin? So one way para makuha natin yung reduction factor natin, pwede tayong tumingin dito sa value ng FS natin. So, bakit po naging 0.9 po yan? Kasi, if we were going to, diba, yung nagiging reference natin dyan, kapag yung actual strain natin is greater than to the value ng, greater than or equal to the value ng 0.005, yung reduction factor natin is equals to 0.19. So, kung gagawin natin yan, di ba, epsilon, that is equal to Fs over 200,000. So, kung yung strain natin dito is 0.005, therefore, yung Fs natin kapag greater than or equal to 1,000, kasi aayusin natin yan, Fs is now equal to epsilon S multiplied by 200,000. Yung epsilon S natin, this is 0.005 multiplied by 200,000. That is equal to 1,000 megapascal. Therefore, if your Fs is greater than or equal to 1,000, the value of your reduction factor, that is 0.90. So kung i-refer natin dito, your Mu now is now equal to 0.90 multiplied by 873.678 kilonewton meter. So Mu is now equal to 786.31 kilonewton meter. So if we were going to refer, Mu is equals to 1.2 M dead load plus 1.6 M live load. So magiging ultimate lang yung MDL natin at saka MLL kapag meron tayong mga factor loads. So meron tayong Mu natin na 786.31 is equals to 1.2. Yung MDL natin na 215 plus 1.6 na mll. So the value of your mll by ship solve is now equal to 330.194 kilonewton meter. So this will now become your answer for problem number 3.